Hi all, in this video I am revising digital integrated circuit, digital integrated circuit unit. I have completed this complete unit digital integrated circuit. Now I am revising this unit. In this video, let me in this video we have studied integrated circuit, definition, IC concept. Next, IC classification. Next, I will write here advantages, IC, and also disadvantages. ICs. Next, applications. Next, applications of ICs. Next, logic families and parameters of logic families. Parameters of logic families. Okay. Now let's recap one by one. IC. Integrated circuit is also called as small chip or we call it as microchip. Okay. Integrated circuits in the sense it's a integrated circuits and electronic circuits in which all the electronic components, okay, such as resistors, diodes, capacitors, transistors are fabricated in a single chip of silicon. Single chip of silicon. Okay. Now, it is called as integrated circuits. Okay, all the electronic components like resistors, transistors, diodes, capacitors fabricated on a single small semiconductor chip. Single small semiconductor chip. That the chip is made up of silicon. Okay. Next, here the IC is also called as a chip, micro, let's say chip or microchip. Next, why ICs are important? Because large number of components in very small size and high speed reliability. I will write as large number of components in very small size. Next, high speed high speed easy mass production, reduced cost. Okay, and because that's why ICs are important. Next, ICs concept. Next is IC concept. ICs was first introduced in 1958. Okay, IC technologies enabled miniaturization of electronic components, and earlier computers used vacuum tubes, which were very large, costly, and power consuming. Okay, um, because of this ICs, vacuum tubes were replaced by ICs because it's smaller size, faster in operations, low power consuming, more reliable. Okay, um, and also low cost, high reliable, etc. Okay, next classification of ICs. Next classification of ICs based on scale of integration. Based on scale of integration. Here SSI, small scale integration. MSI, large scale integration. MSI, medium scale integration. LSI, large scale integration. VLSI, very large scale integration. Next ULSI. Okay, in this SSI, small, the name itself is small scale integration. Okay, here it contains up to 100 gates. Okay, it contains up to 100 gates. And medium scale, it contains up to 100 to 1000 gates. Okay, 100 to 1000 gates. Then large scale integration, 1000 to 20,000, 1000 to 20,000. VLSI, here 20,000 to 1 lakh. Next year ULSI, 1 lakh to 1 lakh to, you can write as 1 crore to 1 crore. Okay, this is very important. I will show you SSI 100 up to 100 gates, up to 100 years. MSA 100 to 1000 gates, which contains 100 to 1000 gates. LSI 1000 to 20,000 gates. VLSI 20,000 to 10,000, 1 lakh. Okay, next ULSI, ultra large scale integration, 1 lakh to 1 crore. Okay, it depends on the application, okay, where we are using. Based on that, then we have to use the ICs. Okay, as per our requirement we have to use it. Next is advantages of advantages of ICs. Okay, here small size, low power consumption, low power consumption, reduced cost. This is a very quick revision video. Okay, reduced cost, less weight, high reliability, etc. These are the advantages of IC. Advantages of ICs are small size, low power consumption, reduced cost, less weight, high reliability. Next, same disadvantages. Next is disadvantages. Disadvantages is poor heat dissipation, poor heat dissipation, cannot be repaired, cannot be repaired. IC cannot be repaired. Suppose if IC fails, we have to replace with new IC only if it damages. Okay. Next is inductors and transformers cannot be fabricated inside IC because they are very, the size is very big. Okay, that's why inductors and capacitors. Next, high value capacitors cannot be fabricated and must be connected externally. Next, next is next topic is Logic families. In this logic family, I've explained to you what is logic families, why logic families are important. Okay, types of logic families are here one is RTL resistor transistor logic, DTL diode transistor logic, TTL transistor logic, ECL emitter coupled logic. Next is MOS metal oxide semiconductor, CMOS complementary metal oxide semiconductor, etc. I explained you in the main videos what is RTL, DTL, TTL, ECL, MOS, CMOS. Okay, this unit is fully theoretical unit. Okay, please understand the concept and write it. Next concept we have studied parameters of logic families. Here in this I will explain you what is parameter, the main parameters of fan in, fan out, power dissipation, power dissipation, noise margin, speed, etc. Okay, in this video we have studied till now. Okay, I think suppose if you refer this video quickly, you can revise the topic what you have studied. Okay. Hmm? Next, and one more parameter is propagation delay. I forgot to write it. Now I am writing propagation delay. Okay. Parameters of logic families: fan in, fan out, power dissipation, noise margin, speed, and propagation delay. Okay. Thank you for your time. Okay. In the next video, I am starting. This completes your digital integrated circuits. In the next video, okay, I am starting Boolean algebra and logic gates. In the next video, I am starting Boolean algebra and logic gates. Okay. Okay. Thank you for your time. Let's meet in the next video.